Model answer video, question 1. We've got organisms getting bigger, they're getting longer, they've got more surface area, they've got more volume, but the surface area to volume is the only thing on this table that's going down. And it's going down because although the surface area is increasing, the volume is increasing more. The volume goes from -18 to 0, and the surface area, the power is 12 to 0, -12 to 0. So the volume is increasing at a much bigger rate. If you're not sure what I've just said, look at the graph of surface area to volume and surface area to volume ratio in your notes. Calculate the surface area to volume ratio. Well, we want surface area to volume ratio. So it's what is the surface area if the volume is 1? So this is going to be a number to 1. And we're doing it of the housefly. So this is the number that we are using. We need to get that to 1. So how do we get that to 1? Well, divide any number by itself equals 1. So 1 expand to -12 divided by 1 expand to -12 is 1. So that's how we get that number to 1. And we also need to do the same to the other number as what we've done. So on both sides of an equation we need to do the same thing. So if we divided that by the volume, we're also dividing the surface area by the volume. So surface area divided by volume. So the surface area is 6 times by 10 to the -8 divided by 1 times by 10 to the -12. And that's going to give us our answer, hopefully. So 6 expand -8 divided by 1 expand -12 is 60,000. So that is 60,000 to 1. So 60,000. Give one advantage and one disadvantage of the tracheal system. As we talked about in the Help Me video, we want the answer to be to do with the tracheal system, not gas exchange systems in general, the actual tracheal system. So we need to grab your insect notes, your revision notes, and go, right, or your booklet notes, and go, I'm going to give an advantage out of that. So why do they have that system? It reduces water loss. Reduces water loss, or allows them to fly about in deserts and things like that. You could give any number of other answers here. You know, for example, other positives about the tracheal system: no blood needed. Or oxygen supplied directly to muscles, O2 supplied directly to muscles, via tracheals and so on. So just one of those points. The disadvantage is a little bit more tricky. This system limits the size of the insect because of the number of tubes required. So if the oxygen levels were higher, we could get bigger insects, and we think there have been bigger insects at some point, but we're limited. So there is a limit to the size of insects. It's not really a disadvantage of that system to the insects currently, because they're happy and they're quite abundant. So it's a bit of a strange question. Use a table to explain why the amoeba does not need a specialised gas exchange surface. So use a table so we can talk about length, surface area, volume, surface area to volume ratio. So there's plenty of things There's a couple of points from the notes that you might not have picked up on, which is diffusion of gases is related to surface area, which makes sense, whereas the amount of oxygen that you use is actually related to your volume, not your surface area. And so if the ratio of those changes, then you might run into problems. So the first two bits of the theory, and very few people wrote this, so diffusion is related to surface area, and I'm writing surface area. If I use SA, I've got to write in brackets somewhere first and then continue to use it. Oxygen use is related to volume. Okay, so those 2 points, most people didn't actually write that down. They wrote this down. The amoeba has a high surface area to volume ratio. You wrote that, which was great. And the other most common point was this length here. Well, the amoeba's got very small lengths. That's the diffusion distance. So the amoeba has a short diffusion distance. So I'm not just saying it's got a short length, because that's just describing the table. We're explaining it. We've got a short diffusion distance, and the combination of these two things means that diffusion of gases is sufficient for demand. So amoeba can rely on diffusion of gases to meet demand. So 5 things you could say there to get you 3 marks. State how mammals maintain the gradient. The key thing here, as I mentioned in the Help Me video, maintain. So here's the mammalian gas exchange surface of the alveoli and blood capillaries, and we have got oxygen moving that way, and we've got CO2 moving that way, so oxygen, CO2. Eventually that will come to equilibrium and diffusion, the net diffusion will stop. So how do we keep that going? Well, we keep that going by constantly moving the air in and out, and we keep moving the blood. So we constantly, let's just talk about oxygen, we're constantly providing air with more oxygen, and we are providing blood with low oxygen, and that maintains a gradient. So in mammals we've got ventilation, or a description about that breathing, replacing oxygen in the alveoli. Then we could talk about the blood. So the blood is taking oxygen away, or bringing low oxygen blood. So blood takes oxygen away, or you could possibly say, blood brings low oxygen blood, and that's maintaining that gradient. As it does say, how do they do it? Suggest why cellular demand for oxygen is lower in fish compared to dog of the same size. So here's my brilliant diagram of a fish and a dog. If you think about where the fish is and what, it can just, it's easier to move around in waters by floating about, whereas a dog actually has to propel itself. The force of gravity has a bigger effect on it. And the fish is, cold-blooded, or it doesn't regulate its temperature in relation to its environment there as much, whereas a dog is, it will have a constant higher body temperature. So those mean that the dog has got a lot more metabolic processes going on, so a higher demand for oxygen. So let's talk about the fish. These questions, if you talk about something, it's the first thing. If you don't mention an animal, it will be the first one that's mentioned. So low body temperature. We've suggested fish are more buoyant, so less energy required for support. So less energy required for support. And so these combine to suggest that we don't need to have as many metabolic reactions working that will use up oxygen. So less metabolic, or fewer metabolic reactions, less metabolic reactions needed that require oxygen. So there's 2 marks there, so any 2 of those will be fine. E is a typical sort of question where we're giving you some information, but the information that we're wanting back is you give us the theory that we've taught you back related to this example. So it's a classic sort of question. 4 marks. So quite a few people have got 2 marks here instead of 4, so it's our job to see if we can get you 4. So mammals evolved with low oxygen conditions, birds when they were higher, and so birds haven't got these adaptations to really get hold of oxygen, and it gives us some stuff about mammalian blood. Biconcave, does not have a nucleus, much smaller. And so down here we want you to give us what you know about these mammalian cells that make them much more efficient than birds. We don't really want you to talk about the birds. So as a starting statement, let's explain why they are this shape compared to birds. So mammalian red blood cells evolved when oxygen levels were lower. That's in the mark scheme as a mark. I wouldn't give you that mark, because it's telling you. All you're doing is repeating some of the question. However, it's on the mark scheme. This is where, in my eyes, the answer really starts. So let's talk about biconcave. So cells are biconcave, and this increases surface area for oxygen absorption. And we just need more points like this. So let's go to the do not have a nucleus. Cells do not have a nucleus, can carry more hemoglobin, can carry more hemoglobin, so more oxygen transport. And smaller size, let's deal with the last one. So cells are smaller, and so anything that's smaller, if we let's draw the bird cells. Well, anything that's smaller has got a higher surface area to volume ratio, so more diffusion. So the cells are smaller, higher surface area to volume ratio. So those are formats. Other things that you can say. Cells are smaller. Again, you can say it's a more total surface area, more total surface area. You could possibly say they're smaller so they can squeeze through thinner capillaries. You could mention more things about the shape. So at some points the diffusion distance is very small. So you could put another biconcave. Some areas very short diffusion distance. So you can see we're wanting you to tell us the things about what you know about what you've learnt about this, and not waffle on about birds.